Playing the same game again, but backwards. Okay, so in our last video, we looked at going from polar notation to rectangular notation. This time, we're going to flip it. We're going to start with rectangular, x comma y, and we're going to go to polar this time. So how can we do this? Well, if I recall, I have something from geometry known as the Pythagorean theorem, which states that a squared plus b squared equals c squared. And that's actually what we're going to apply here. This equation up here is actually just the Pythagorean theorem here. It's pretty much a squared, b squared, and then c, and that's because I took the square root of everything to get rid of the square. We also know from SOHCAHTOA that I can find angles using inverse functions. That's inverse sine, inverse cosine, inverse tangent. We're actually going to stick with the inverse tangent here for what we're using. Okay. Now what we're going to do is we are just going to set up a triangle, and then with that triangle, we're going to be very clever about, let's pick the proper angle that we should be sitting at. Okay, so I'll show you how to do this along the way. In our example here, what we have is a plane, and our plane is starting from point A right here on the grid, and is traveling out here. And to do so, it is traveling 44 kilometers to the west, so it's going to the west by 44 kilometers, and then it's going 33 kilometers north. Now, it's not actually going left and then up, or west and then north. It's taking the angle. It's taking the direct path there because it's an airplane. It can take that straight line. So it's actually going along this red path here. But I don't know what the value is for that path. What is that actual distance? How can we get that? And what angle is that located at? What is that heading? So here's how we can go about this. If we take a look at this triangle, which is a right triangle here, we quickly see that we're looking for the hypotenuse. And as I mentioned previously, this is just a Pythagorean theorem. So I will just take the sides here, the 33 and the 44, and put them in for the x and y values for our equation, because this is the amount we went in the x, this is the amount we went in the y. Okay? So if we go ahead and plug these in, we get the square root of 44 squared plus 33 squared. Now, if you were like, hey, Mr. Botzer, that plane's going to the west, I'm calling west negative. Should I put the 44 in as negative? It doesn't matter. If you put the negative in for the 44, whenever you square it, that negative times a negative is going to give a positive no matter what, so it's going to go away. So because we know that, I don't even bother thinking about that negative sign there, okay? I just say, look, it's just the magnitude is what I'm looking for. I'm squaring everything and then taking a square root. I'm going to be good here, okay? And that will give us our R value, or our hypotenuse here. So if we plug these into your calculator, maybe you're looking at these numbers and you're recognizing what they probably are going to be. But if you type in 33 squared, you get 1,089 plus the quantity of 44 squared. You get 3,025 after you add those together. When you take the square root of that answer, you get 55. And that's technically just a scaled up 3, 4, 5 triangle. It's 3, 4, 5, but scaled up by 11. So that's kilometers there. So that is what our hypotenuse is. Okay? So if we wanted to write this out in polar notation, what we have so far is 55 kilometers, comma, and now we need to get this position. We need to get the position angle. We need to figure that out. So what we can do is this. Let's figure out this green angle on the inside. Okay? Let's figure out that angle first. So I know I can use arctangent for this because what I have here is the opposite side and the adjacent if I labeled my triangles. So if I wanted to find theta, I can just say, hey, look, this theta here is the inverse tangent, because that's what I use if I have opposite and adjacent, of the opposite, 33, over the adjacent, 44. And since those are both in kilometers, the units will cancel out, which is exactly what we want for the angle. And if we take the inverse tangent of 33 divided by 44, we're going to get an angle here of 36.87 degrees. Okay? Now, if we put 36.87 degrees up here into our actual value, we'd be wrong. We don't want that. Remember, the angle we want is actually all the way around. So while this angle in here is the 36.87 degrees, we actually want the purple angle out here. And to do that, there's two ways we can think about that. We could recognize that these angles have to match up and add to 90 and do 90 plus whatever the missing is, but I think of it easier as going the 180 minus the 36.87. So 180 minus the 36.87 gives me an angle of 143.13. Okay, that's because going from one edge to the other on a flat line is 180, and then I just take off that 36.87. Okay, so with that, that is how we can go from a rectangular notation in x comma y and get this back into a polar notation to use later on. Okay, so with that, we are finished. Adios. Take it easy.